Hello team, and in this lesson we will learn about the maintenance window in Kubernetes cluster. Maintenance window means due to some reasons if we need to remove some nodes from my cluster and after the recovery we again need to add that node in a cluster, then how can we do such activity gracefully? So here we will discuss how can we remove a node from a cluster, and we are going to discuss about these concepts. We will discuss what is node draining and how we can drain a node from a Kubernetes cluster. What are the daemon sets and how we can ignore the daemon sets while we are draining the nodes? What are the uncordoning of a node in Kubernetes cluster? And then we will go with demonstration. So let's start with what is node draining. Whenever we are talking about node draining, we means we want to drain out a worker node from the Kubernetes cluster. We need to remove a node from a Kubernetes cluster, and there could be the multiple reasons to removing a node from a Kubernetes cluster. Sometimes we need the maintenance window, and in that maintenance window we need to apply some patches on the worker nodes, or we need to add something within a worker node, like we want to increase the capacity of my worker node, or I need to attach some additional disk with my worker node, I need to apply some security patch. So there could be the multiple reasons whenever you need a maintenance window on your running cluster. And in that maintenance window, what we will do, we will remove the faulty node from a cluster, apply the patch or fix that node, and again add that particular node in a cluster. That all process is called the node draining. And whenever we are performing the node draining, we need to be make sure that the application which is running in a Kubernetes cluster, that should not be impacted. It means there should be no downtime in the application which is running on the Kubernetes cluster. It doesn't matter that we are in the maintenance window or we are draining out the nodes. So draining a node in Kubernetes is a process, and whenever we are draining a node from Kubernetes, we need to make sure that the containers which are running on that particular node, they will be gracefully terminated, and they will be rescheduled on the another available worker nodes. That is called the draining or node draining in Kubernetes. There are standard process to drain a node in Kubernetes. You can use the kubectl, or you can use the kubectl utility to drain node in Kubernetes, and there is a simple command kubectl drain. Then you need to provide your node name. But whenever we are draining a node, we need to make sure that no daemon set is executing on that particular node, and if daemon set is executing in that particular node, then we need to pass ignore daemon set parameter with the drain command. What is the daemon set? Daemon set means there are the pods that are tightly coupled to that node. It means sometimes we have a requirement that I need to execute a particular process on all of my worker nodes. That could be the monitoring, that could be the health check, that could be the performance check. So these kind of pods which are running on each node in the Kubernetes cluster, they are called the daemon set. And in any case, if any daemon set is running on your Kubernetes cluster node, then you cannot drain the node easily. For that you need to execute a command kubectl drain, provide your node name hyphen hyphen ignore hyphen daemon sets. Now once you drain the node, you put the fix on that node, and if that node is still a part of the cluster and you want to allow the pods on that particular node, you want to allow that master can schedule the additional resources or additional pod in that particular node, then you need to uncordon that particular node, and you can do that with the command kubectl uncordon, then provide your node name. Let's demonstrate all the things we have discussed about the node draining. So we will create a SSH connection with my master node. We have already set up a HA Kubernetes cluster in last lecture. So this is my master node IP. Here you can see I am on my Kubernetes master node. Let's get the number of nodes which are part of my cluster. We'll execute kubectl get nodes, and these are the nodes which are part of my cluster. Now let's execute a command kubectl get pods -o white. What this will display? This command will display all the pods which are running within my cluster. Also, it will display on which particular nodes the pods are running. Hit enter, and it is saying no resource found in the default namespace. It means nothing is executing in my default namespace. What we will do, we will execute few pods and deployments on this node. So we will create a directory mkdir node draining, Now we will go to this directory, put ll. So we don't have any file over here. Let's create some file over here, and I will call this file pods.yaml. Within this file I will paste this content. And what is this content? So right now I'm not explaining much about it, because this is the YAML file to create a pod, right? Once we will learn about the pod, I will explain each and everything in quite details. Right now I will just copy this and paste it here. Let's save your file. And to execute that particular YAML file, you need to execute command kubectl apply -f and define your file name, which is pods.yaml. So there is some error within my YAML. I need to correct that error. Now we have corrected the YAML file. I will execute this again, kubectl apply -f pods.yaml. And you can see the new pod got created, draining nodes test pod. This is the same name we have provided to my pod. See, training node test pod. If you want to execute the get pods override again, you can execute that command. And you can see one pod is running, and that pod is running on worker node 2. Now what I will do, I will create one more file, and I will call it deployment.yaml. Here I will create the deployment content. Let's see what is the content we are going to push over here. So here I have created the deployment content. So this is the content. Here we are creating a deployment. The deployment name will be training node test deployment. This is going to create the two replicas, right? And again it is executing the nginx latest image. Team, again, once I will execute the deployment, I will explain each and everything in detail. Also, we need to explain few more concept about the deployment. But right now, what you need to do, you just need to copy this file and paste within your terminal. So I will paste it here, save the file. Now again, I will execute kubectl apply -f and define my deployment YAML file. Hit enter, and you can see the deployment got created. We have created a pod and we have created a deployment. This kind of setup is intentional. This kind of setup is intentional because I want to show you that, how draining will treat, because I want to show you that how node draining will treat deployment and pods in a different manner. I will clear out the console and execute the get pods command again, kubectl get pods -o void. Now you can see my deployment ports are these two ports are my deployment port, and this is a port which I executed. The deployment ports are running on worker node 1 and worker node 2, and my pod is running on worker node 2. Now what we will do, we will drain out this node 2. So I will copy my node name and execute a command kubectl drain and provide your node name. Let's hit enter, and we are getting an error. It is saying unable to drain the node, aborting command. What is the reason we are getting? We are getting two reasons over here. Cannot delete pods not managed by the replication controller, replica set, job, daemon set, and stateful set. And it is talking about the pod which we created. It is saying that this pod which is running on this particular node, that is not connected with any of these objects. What are these objects? I will explain these things in the coming lectures. But right here it is saying that this is a pod and this is not connected with any of these objects. And what is the second error? Second error is about the daemon set. What is the daemon set? Daemon set is a process where pods are running on each node. Here we can see these two pods which are the part of same deployment, and they are running on each node. First pod is running on worker node 1, another is running on worker node 2. This is a daemon set. So it is saying that daemon set that cannot delete the daemon set managed by the pod. And these are the daemon sets, right? Kube system Calico network is the another daemon set, and kube proxy is another daemon set. These are also the pod which are running on worker node 2, right? So how we can drain out the node in this situation? We will execute the same command, and plus this time I will provide this argument. Ignore daemon sets. Let's enter, and we will get the error again. Yes. Why we are getting error this time? The second error is gone, but we are still getting the error for my first reason. It is showing the error for this pod, right, which we are executing explicitly on this particular node. So does it mean we cannot drain this node? No. How we can do that? After this, we will append hyphen hyphen force. Hit enter and see it is saying node 2 is already called on and it is evicting the pods. This is the pod which is got evicted. This is the another pod which is got evicted, and these are the two pods again. Right here it is saying node K2 cluster worker evicted. Let's clear out the console and execute a command kubectl get nodes. Hit enter. See, we are getting that this is the master node status is ready. Worker node 1 status is ready. Worker node 2, which we just trained, it is saying ready, scheduling disabled. It means no new resource will be scheduled on this particular worker node. Let's execute the get pods command again, and you can see the pod which we executed explicitly, that is being removed, but the pods which was the part of my deployment, that is rescheduled. This is the pod which was originally working on the node 1, and this is the another pod which newly created on the node 1. See, the age is just 64 seconds. So as I told you, once you will drain the node, the pods which are running on that particular node, they will terminate gracefully and rescheduled on the available worker node. So that is the case which happened over here. But the pod which we executed explicitly on that particular node, that is removed. So it will just manage the pod which are the part of replica set, replication controller, stateful set, and the jobs. And each and every component which I just mentioned, I will explain each and every component in quite details in the coming lectures. Now suppose I want to rejoin that particular node which I removed from my cluster. So how we can do that? We will execute a command kubectl and we will mention uncordon and provide my node name, which is this. Hit enter button and it is saying node to uncordoned. Execute the get nodes command again and see this is ready, right? The node is again joined the cluster. Let's execute the command again which was getting the pod, and you can see there is no change in the state of the pods. So it means you can remove the nodes from a cluster, rejoin the node within a cluster, but it does not guarantee that the existing pods which has been rescheduled to the another node, they will again execute on the fixed node, right? The only way to move these pod from this particular node, you need to remove the first node this time and fix your problem and rejoin the first node. So this all process is called the node draining in Kubernetes, where we can easily drain the node from the Kubernetes cluster, fix the thing whatever we want to fix, either that is a reboot or any other thing, right? And then we can again join that particular node within the cluster. So thank you team. See you in the coming lecture.